Good afternoon, guys. Welcome back into my channel. So in this lecture and lab, we're going to talk about network devices, access control, and infrastructure security. And at the end of this lab configuration, we're going to configure Syslog and NTP. So basically, this is just a brief skim into this chapter. So you will see different things here, like access control list ACL. So to be on the safe side, I might as well speak about this um on the next lab. Now, see something here. We have here again, just so you know, this is a PDF version of the CCNP and CCIE Enterprise Core Encor 350-401 official set guides. So you could have this book for free. I'm going to leave a link of this book in the bottom of each of these lectures. So let me go ahead and just talk about this interesting topic here that we have. Let's try to see if we can understand together. So since the lab that we're going to have at the end of this lecture is to configure Syslog and NTP, so let's understand what is Syslog before we start doing configuration. So the question asked here is that what is Syslog? So Syslog stands for System Login Protocol and is a standard protocol used to send system log or event messages to a specific server, so-called the Syslog server. It is a primary used to collect various device logs from several different machines in a central location for monitoring and review. So the protocol is enabled on most network equipment such as routers, switches, firewall, and even more printers. Even some, I'm sorry guys, even some printers and scanners. So in addition, Syslog is available on Unix and Linux-based systems and many web servers, including Apache. Syslog is not installed by default on Windows systems, which use their own Windows event log. So these events can be forwarded via third-party utilities or other configuration using the Syslog protocol. So Syslog is defined in RFC 55424. The Syslog protocol, which obsolete the previous RFC 3164. So Syslog components. Let's go ahead and make this. So on any given device, various events are generated by the system in response, in response to changing conditions. These events are typically logged locally where they can be reviewed and analyzed by an administrator. However, monitoring numerous logs over an equally numerous number of router switches and systems would be the time consuming and unpractical. So Syslog helps solve this issue by forwarding those events to a centralized server. So Syslog transmission. Why don't we go ahead and make these red and center these. And let's make these red and center that too as well. So Traditionally, Syslogs use the UDP protocol on port 514, but can be configured to use any port. In addition, some devices will use TCP 1468 to send syslog data to get confirmed message delivery. So syslog packet transmission is asynchronous. What causes a system message to be generated is configured within the router, switch, or server itself. So unlike other monitoring protocols such as SNMP, there is no mechanism to pull the syslog data. So in some implementation, SNMP may be used to set or modify syslog parameters remotely. So syslog message format. Let's go ahead and make this red and send this. Oh, sorry. Let's say Control Z. Tell you what. Let's make this red. Select and center here. Okay, so the syslog message consists of three parts. PRI, a calculated priority value. Header, which identify information. And MSG, the message itself. So it talks and explains the PRI data set via the syslog protocol comes from two numeric value and help categorize the message. So the first is the facility value. This value is one of the 15 predefined value of various locally defined values in the case of 16 to 23. So guys, so these are the numbers and facility description. So number 0 is kernel message, 1 is user level, 2 is mail system, 3 is system demands, 4 is security authorization message, 5 is message generated by syslogs, 6 is line pointer subsystem, 7 is network news subsystem, 8 is UUCP subsystem, 9 is clock demand, 10 is security authorization message, 11 is FTP demand, 12 is NTP system, 13 is log audit, 14 is log alert, 15 is clock demand, and 16 to 23 local use from 0 to 7. So these are very important for you to know in order for you to understand what syslog. So the second level of syslog message categorizes the importance or severity of the message in a numerical code from 0 to 7. So 0 is emergency, system is unstable, 1 is alert, action must be taken immediately, 2 is critical condition, 3 is error condition, and 4 is warning condition, 5 is notice, normal but significant condition, 6 is informational messages, 7 is debug level message. So guys, now I'm not gonna wait too long for this for the sake of not making this lecture too long, because on the previous lecture it was a super long one. So let's go ahead and just make a brief talk. So this is an architecture. This is a workstation, the application server, the syslog message, syslog server, devices, servers, and workstation too as well. So good. Like I always said, you could pause and or skip if you understand these terminologies. So, but if you don't, you could pause these and take a look at it and study to make sure that you understand these. So now let's go ahead and talk about, since this lab today is to configure Syslog and NTP, So let's go ahead and says syslog login and NTP. So login messages and event both locally to a syslog server is a core maintenance task. So syslog is a protocol that allows a host to send event notification messages across IP networks to event message collectors, so also known as syslog server or syslog daemon. So in other words, a host and a device can be configured in such a way that it generates the message, a syslog message, and forward it to a specific syslog daemon server. So you can learn more. So that's just an article that we find, but this course here is in CCNP level. So syslog daemon, so bang bang bang, UDP, so syslog. Now, as you can see here, it talks about the same that we just repeat earlier. So that's just like couple different commands to configure syslog, which you should know already. So guys, what we go ahead and pull packet tracer and start our lab for today. So it says to configure syslog NTP. So the objective is to configure syslog service, generate logs event, manually set switch clocks, configure NTP service, verify timestamps log. So first thing first, what do we do? So it says to enable the syslog service, click on the syslog server and then click tab. It's the syslog server. Then says to click on the syslog server, which is this. It says click on the syslog server and then select the service tab, which is this service here, and then turn on the syslog service. So turn the syslog service on and move the windows so you can monitor activity. So the syslog say turn it on. Then it says to move this so we can monitor activity. Okay, so this was the first thing that we had to do. So the second step says to configure the intermediary device to use the syslog service. So on router 1, let's go ahead and pull router 1. Says what do we do? So as you know, so enable conf t, then login. Is okay, so it says configure S1 to send. Okay, enable the syslog. So on step 2, we're going to configure the intermediary device to use the syslog service. Router 1. So let's go ahead and do for switch 1. So configure, let's do this. Oh man, that's not good. Get a typo here. So what we're gonna do, we're gonna configure switch 1 to send log events to the syslog server, and we're gonna do that too for switch 2. We just get a typo on this, we just get a typo on this. Let's just wait for it a little bit. Packet tracer when you get a typo, so instead of type in the the enable, I put one enable, just okay. So now we can continue. So enconf t, and then we do so the login server, which is this IP address here. So let's go ahead. Now let's do that for router 3. I mean for switch 2, not router 3, I'm sorry. So enable conf t and paste this. Now, in part 2, we will generate the logs event. So we're going to configure a loopback 0 interface on router 1 and then disable it. So router, let's go ahead and create a loopback. So we gotta say int loopback 0, and then we do shutdown. Okay. Okay. So we have to turn on PC1 and PC2, turn them, I mean, we have to turn off PC1 and PC2 and turn them back on again. So PC1 and 2, let's go here, let's check for physical, zoom in, see, so we turn it off, then we turn it back on, you see, and that's for PC1. Let's do the same for PC2. So we zoom in, we turn it off, right? Then we turn it back on. So let's check to see. Yep, so we turn them off and turn them back on. Now, what do we have? So we're going to examine the syslog events. So we're going to look at the syslog event, and all of the events have to be recorded. However, the timestamp may be incorrect. So um so just a second. Okay, so what we got to do here. Okay, so so we have to manually set switch clocks. So do that. So to do that, we have to grab this clock switch 1 and just type it in. Okay, so we shall end. and then paste. Okay. And we got to do that for switch 2. Okay. So now we have to enable the login timestamp service on the switches. So let's see. So enable the login timestamp services on the switches, so switch 1 and 2. So let's go ahead and do that. On switch 1 first. Conf T. And that. So let's go on switch 2. Conf T. Paste. Enter. Okay. So now we have to configure the NTP service. So in this activity, we are assuming that the NTP service is being hosted on a public internet server. So if the NTP server was private, the authentication could also be used. So turn on the NTP server and open the service tab for the NTP server and turn it back on so the service, and note that the date and timestamp is displayed. So let's go ahead and do that. So there go the NTP server right there. Let's grab it. It's IP. Tell you what, let's just push this a little bit so the whole IP will show. So you got to go to service, and then tab to the NTP, this, and you got to turn it back on. Okay. So it says here, so turn on the NTP service on and note that the date and time that displays. So it's the same date and time that oh no, that's just different a little bit. Okay, so in step 2, it says automatically set the clock on the router. So let's go grab the router. So set the clock on the router according to the NTP server. So there go the IP of the NTP server. Let's exit out just one. And then paste. Enter. So issue the show clock command to view the system clock settings. It can take time for the Syslog clock to be updated to the time that is configured on the NTP server. If the system clock has not updated, click the fast forward time button and until the router system clock is synchronized with the NTP server. So we have to do a do show clock. So see if this time is compatible with the NTP server. So even though it's not, it says that it might take some time before it is. Or else we would have to, press the fast forward button to make this work. Now, there's no need for that because our configuration and all the commands are correct. So now it says that to verify timestamp logs. So to verify timestamp logs, So we have to change the status of the interface to create an event logs, and we enable and then disable the loopback 0 on in interface on router 1. So let's go ahead and do that. So how about we just do this? Okay. So on router 1, let's say interface loopback 0. So no shutdown. So we turn it back on, and then we shut it down. So we create an event. So now let's turn off laptop 1 and laptop 2 and turn them back on. So laptop 1, stay physical. Let's zoom it. Let's turn it off. So you see it's off here. Let's turn it back on. As for laptop 1, so let's go on laptop 2. Zoom in, scroll, turn it off. As we turn it off, you can see, and let's turn it back on. Okay, so now it says examine the syslog events. As the syslog event, look at the syslog event. All of the events have been recorded on the timestamp are correct and configure on router 1. So use the clock settings on the NTP. Use the clock settings on the NTP server and switch 1 and switch 2 to use the clock settings that you configure in part 3. So let's do. So we get a different date now, and this should be compatible with the NTP server now. So you see it. So now we get it. Now, okay, so now let's check this. And check switch 2. So these have almost all Friday, July 10. Switch 2 have the same time with, yep, so switch 2 have the same time with switch 1. So basically what that is see if we miss anything. See if we miss anything here, guys. So if you were to go on Syslog here, so we have timestamp, NTP server. Let's check this. That's the syslog. So the logos is on, and the NTP so this here, once we do this, we have to just verify this. So let's say loopback 0, and then shut it down. It should be done on the syslog. It's the syslog. Let's see. Let's just scrub. Where is it at? Just to avoid So guys, let's go ahead and just look. Where's the syslog? Where is it at? Okay, so let's see if we can close it and turn it back on, because we can't find it. Let's go on syslog. The syslog. So here's what we should do. And that's what we monitor. So we should turn off. Let's go on water one, and let's do, so we shut it down, and then we no shutdown. So let's monitor the syslog. So basically, you see the syslog message, it shows everything. So all we do was to making sure when events happen, let's say if we were to go on, when we go on this interface, when we shut it down, so you see the syslog server is already monitored, something happened. Let's turn it back on, you're gonna see the syslog is monitored this. So that's the whole purpose of this lab. So if we do that too for the PC2, let's just zoom. Let's zoom in. Let's turn it off. So you see, it shows it's just turned off. Let's turn it back on. You're gonna see another message again on the syslog. So if you go to the laptop, let's zoom in and let's turn it off. You're gonna you're gonna see a message, right? And let's turn it back on. So our configuration is good so far. Let's do it for laptop 2 as well. So everything is monitored by the syslog server. So we turn it off. So you see message saying that it's turned off, and let's turn it back on. So the message, so it's turned it back on. So try to go on the GUI here. Let's say we do so IP config. So how about we do a tracer? Let's see something. Tracer 664.103.224.2. So laptop 2, let's go here. So we good. So guys, thank you so very much. I appreciate you guys was following along. So it passed from this IP to 09, that's 60, that's 165, that's 14, that's 1, which is which device? Let's see. Not sure what device that is. That's probably the one. So do show IP at beyond. Okay, so it's the serial interface, which is this one here. Okay, the router. All right, guys, thank you so very much. Stay tuned for another lab and lecture. I'll see you next time. Bye-bye. So the main purpose was to monitor to configure Syslog and on the NTP server. So we done that. It works very fine. Thank you. I'll see you in the next lab.